we reading him first?
All right. I'm going to show you how I might do a problem that looks like this. Same directions. Solve for all values of x between 0 and 2 pi. Okay? What I'm going to do is actually ignore the 3x for a moment and think, when is cosine equal to 0?
90.
At 90 and
Pi over 2.
270.
Oh.
Or at, you're right, at pi over 2 and 3 pi over 2. Okay? So in other words, if underneath my hand is 90 or 270, I know those are some solutions. So I'm going to take this amount, this 3x, and set it equal to those values that I know are solutions. So I'm going to set, I'll use degrees here to make it a little bit easier on you for the time being. I'm going to set 3x equal to 90 degrees. Because I know that if 3x is 90 degrees, I know that's a solution. Because I know the cosine of 90 degrees is equal to 0. But I also know if 3x equals 270 degrees, that is also a solution. Because I know the cosine of 270 degrees is also equal to 0. Now let's just solve both of these. Divide by 3 and I get x equals 30. Divide by 3 and I get x equals 90. Do you think these are all the solutions between 0 and 360 or between 0 and 2 pi that there are?
No.
There are going to be more. Whatever the coefficient is in front of the x on a problem like this, go around the circle that many times. Okay? And you'll see how you continue to still get answers, though, that are between 0 and 2 pi. Because right now I just have pi over 6 and pi over 2, right? Right? Let's go around the circle again. So I know that if this was 90, cosine of 90 is equal to 0. So I go around I hit 90, I go all the way around the circle, 360. When I get up to 90 again, that's actually 450, right? So if 3x is equal to 450, would that satisfy the equation? Is the cosine of 450 equal to 0? It is, so let's set 3x equal to 450. Notice that when I solve this, do I get an answer that's between 0 and 2 pi? Yes, I do. So let's keep going. So I've gone once around the circle. I hit 450. Down here it would be 630. Okay? So I'm going to set 3x equal to 630. I'm going to divide by 3 and I get 210. Which you guys know is 7 pi over 6. Let's keep going. So I went all the way around once. That's 720. Up here would be 810, right?
Yep.
Divide by 3 and I get 270. That would be 3 pi over 2. We got to 810, 900, 990. So 3x equals 990. X equals 330, which is 11 pi over 6. We can go one more, that's fine. So we're at 990, we're at 1080. To get back up here where we want to, remember all of them are 90 or 270, that'd be 1080, 1170. If I set 3x equal to 1170 and then divide by 3, I get 390, which would be 13 pi over 6. But guess what? That's outside of my range that I wanted my answers, remember? I only wanted answers between 0 and 2 pi. And isn't 13 pi over 6 exactly the same as pi over 6? So I don't need to include that answer. I have found every single possible answer that's between 0 and 2 pi. This coefficient will pretty much tell you how many times you would need to go around the circle to find all of your answers between 0 and 2 pi. That's how I would do one with a 3x there.
Please don't make us do like 5.
Mm-hmm.
Please don't ever put 5 in front of the x.
Right, 3 is probably as high as I'd go. Alright, so there's kind of a triple angle possible answer. Low battery again. Still running though. Alright. I'm gonna try to make one up here off the top of my head. This might not work out right. Let's see. Let's go cosine of 2x plus sine x equals 2. I might have to change that. This is probably about as tricky as they might come. This is going to be tough because I have a cosine here and a sine here. They're not the same trig value. But don't we have some identities for our double angle? There were 3 identities for the cosine of the double angle. One of them was cosine squared minus sine squared. One of them was 2 cosine squared minus 1. And another one was 1 minus 2 sine squared. I'm going to choose that last one, 1 minus 2 sine squared, because then I'm going to have everything in terms of sines. That way I get my equation where it only has sines in it. If those of you that have not studied the double angles yet right now are probably completely lost. Okay? Cosine of 2x I'm going to replace with 1 minus 2 sine squared x. Now I have a quadratic, so I'm going to hope that I can factor it. But in order to factor a quadratic, I like having my quadratic term be positive, so I'm actually going to move everything over to that side. When I move this negative 2 sine squared x over to the other side, now I have a positive 2 sine squared x. When I move this sine x over to the other side, I have minus sine x. And when I move this 1 over to the other side, I'd still have a plus 1.
What did you do with the 2?
What do you mean, what did I do? I subtracted 1 from both sides. When I subtract 1 from both sides, don't I get 1 over here? Yeah, this is what I get for trying to make up a problem off the top of my head. I needed that to be a negative 1 over there.
Just fix it.
So we're going to make this a 0. We're going to make that a 0. So then when I subtract 1, I get minus 1 back there. Now I just factor like I did earlier today. That'd be 2 sine x, minus 1 here, plus 1 here. I know I'm going fast right now, just trust me, I'm decent at factoring. Okay, and then what do I do with each factor? Set them equal to 0 and solve. Okay, so this one you had to incorporate a double angle to help you solve the function. If you know your identities and you know your time test values, the standard is not difficult. Okay, without knowing those things though, this is very, very difficult. Alright, so you gotta make sure you know your time test stuff, and you gotta know all of your identities pretty well in order to do this standard. Okay? I'll have practice for you to work on starting tomorrow.
When do you think this test is okay?